Welcome. This tutorial covers knowledge graph RAG, combining graph structure data with RAG for precise relationship-aware retrieval. Instead of relying solely on vector similarity, we organize knowledge as interconnected entities and relationships, then traverse connections to answer complex questions. For demo, we use Neo4j Aura free cloud tier to avoid local installation or Docker setup. Let's compare vector RAG search and graph RAG search. Vector RAG search is powerful but fundamentally fuzzy. You search for semantic similarity, get the top K results, and hope they are relevant. But if our problem is highly structured, such as who wrote the screenplay for movies directed by Christopher Nolan, this is not a vector similarity problem. This is a relationship problem. First, we need to find the entity, that is Christopher Nolan here, and find the movies he directed. This is a directed by relationship. And find the writers of those movies, that is written by relationship. Now let's take one more example. Let's consider this who directed Inception. In case of semantic search, it uses some top K results. LLM uses that top K results and generates the answer. Now in case of graph RAG search, the same question, graph RAG search will do graph pattern matching, that it identifies entities and relationship, gives us the structured results. LLM uses that structured data and gives us the answer. The key advantage of graph RAG search is it helps to understand the relationship, more accurate and contextual answers, multi-hop reasoning, richer explainable results, handles complex queries, and consistent knowledge. Here is one more example. If you see, the query here is who directed Inception and which movies did he direct before that. So now Inception is an entity, Christopher Nolan is also an entity, directed by is relationship here, and directed before is also a relationship. This graph RAG search excels at multi-hop reasoning, that is traverse chain of relationships. This is best suited for most of the domains like healthcare and life sciences, legal and compliance, finance and investment, e-commerce and retail, IT and cybersecurity, education and research. Almost most of the domain will benefit from graph RAG search, where we can identify entities and the relationships. First, we have to create a free account in Neo4j Aura for this demo. First, search for Neo4j Aura. You'll see this link. Click on this link and click Start Free. Once you create an account, create a project here, then create instance. Select give it a name and create instance. This is the username and password. Click download and continue. Allow it to create the instance. Now let's navigate to Visual Studio Code. We need a Neo4j dependency. Let me add that. Spring Boot starter data Neo4j. Let me save this. Now in application.yaml, we have to configure some properties. We'll update those properties. We update these details from the downloaded file. Let me copy this URI, then username and then password. Now our configuration is complete. I have also created a class called knowledgegraph.java. It's a record type. Inside it, we have node record and edge record. Node record represents entities and edge represents relationship. I'll create a controller class. I'll name it graph controller. I'll annotate this class with REST controller. Define a logger. And we have to inject 3 beans: chat client, Neo4j client, and Redis vector store. Let me accept this coding suggestion. We have to do little modification for the chat client, that is chat client.builder and chat client.build method. Let me import this logger. First, let me define a post mapping API. I have named it graph extract, as we are using LLM to extract entities and the relationship in our text prompt. Let me directly call chat client.prompt.user. We'll pass this text with the extra information. Ask LLM to extract a knowledge graph from the following text, whatever passed here. Identify key entities and their relationships. For each node, provide ID, label, type, and properties. That's what we define here. Each node has ID, label, type, and a map of properties. For each edge, provide source target relationship. Here also we have defined source, target, and relationship. And we pass our text here as parameter. I'll invoke call method, then entity. We'll say knowledge graph dot class. So the response from the LLM will be in this structured format. Let me import this request body from the Spring framework. Finally, we return this response. We'll build our application and then mvn Spring Boot run. I'll bring up the Postman. I have already added this API here. Post mapping graph slash extract API. We are expecting a JSON with text property. Let me hit the API. So here we have the response. Nodes, Christopher Nolan, inception, and edges, that is relationship directed by AxIn. So our LLM successfully extracted the nodes and the edges. Now in the next API, we'll store extracted information in Neo4j. So this API expects a knowledge graph. We loop through each node and store it in our Neo4j. The ideal practice should be we should create a service and we have to call that service to do all this job. For simplicity, let me do it here itself. So this is our query. Merge this entity with label, type, and set of properties. Similarly, we loop through each edges and store it in Neo4j. So the query used here will be match entity source and entity target. Merge relates to the relation type. Now let me define a log statement here and then return map of status, nodes, and edges saved. Now I have this output from previous API call. Let me use that output and use it here in the slash graph slash store API as JSON, raw JSON. Let me go back to Visual Studio Code and build this application and run. Now in earlier API, we used this text. Christopher Nolan directed Inception in 2010. The film stars Leonardo DiCaprio and is a science fiction thriller. We have output for this text as nodes and edges. We are using the same output to store it in Neo4j. I'll hit this API. So it stored 4 nodes and 3 edges. Let's define a get mapping for querying the Neo4j. I have named the API graph slash query. Let's define the method signature which accepts a question. Let's define a private method for adding query logic. Here we will use a string builder to return query responses. First we query the nodes, then query all the edges. Now append nodes and edges to string builder. Then return string builder to string as a string object from this method. Now we use this method here in the API. First fetch all the entities and the nodes using the methods just defined. Let's do a check. If it is empty, we will just send a response that knowledge graph is empty. If it is not empty, then we log the graph context. Then we call chat client.prompt. We pass system instruction. We say you are a knowledge graph expert. Answer the question using only the graph data provided below. If the answer is not in the graph, say. If answer is not in the graph, say so. Knowledge graph and the context we already provided. Then pass user prompt, that is question, then invoke call method, then extract the content. Let's save this in the string field answer, then return map of question and the answer. Now we have our API ready. Let me build the application and run. I'll bring up the Postman. I have already added this API here, /graph/query. The question is, what movies did Nolan direct? Let me hit the API. So, according to the graph, Christopher Nolan directed Inception. Now we have the answer from LLM using our graph knowledge, which is stored in Neo4j. Now let's look at the dashboard here. Click on this dashboard, connect to instance and connect. Let me click create with AI, continue, show all what is available. So there are total 4 number of entities, total number of relationships. I clicked explore here and I'm clicking show me graph. So here you can see the graphs, entities, entity, 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 relation, relationship, relationship. Let me wrap this tutorial here. In the next tutorial, we will look at hybrid search. There we use both vector store and the graph store, and we send that context to LLM and we get the answer. See you there.